G'day viewers, I'd like to show you an easy way on how to understand the resultant magnetic field of the three-phase induction motor and how it rotates. I'd like to take you back to the first year of college where you did magnetism. So if you've already done magnetism, you'll understand the bar magnet concept of the electromagnet and as to how the current going through a cable has a flux going around it. So I'll start back at if we've got a single conductor. So here if we've got a single conductor and if we've got a current coming towards us, then if you remember your grip rule, so in the current coming towards us, then we're going to have a magnetic flux that is going in that direction. If we have more of these conductors together and the current's going in the same direction as they're side by side, we don't have a magnetic flux that goes in between them. They combine together. So if you remember, the flux from this and that one combine together, and that then will tell us that the north pole is at that end. And then of course, if you could imagine that this here is a coil, and so we've got the other conductors that make up the rest of the coil. So this is a coil that is wound, and so what we've done is we have cut through that coil. If the current is coming towards us there, then it's obviously going into the board here. So here's our current going into the board. So you remember that. Three-phase induction motor is no different. So let's say that we take this conductor and we move that out of the way. We take this conductor, we move it out of the way. Okay, so now we've got basically still a bar magnet, but it's now circular. Same concept applies. Magnetic flux around these combine together, and there's your resultant magnetic flux. These ones down here, they combine together, that's your magnetic flux. Okay. But, of course, now we're not in DC like we did in our first year. So we've got AC, and it's a three-phase supply. So imagine you've got your sine wave. Whoop, not a very pretty one. You get the idea. As we go through time, now the direction of this flux is going to change. So we'll start at this end. Let's imagine that now instead of the flux coming out towards us, instead of the current coming out towards us, we've got the current going into the board. And its opposing conductor down here now has the current coming out of the board. So now these conductors here will combine and we'll get a resultant flux in that direction. So now the north pole of the magnetic field has changed. It's moved, effectively rotated. Now of course if you imagine as time progresses, we've got current going into the board, and at the other end we'll have the current coming out of the board. Those conductors, the flux will combine, and we've now changed our magnetic field again. So we've rotated it further. And then of course, you know what's going to happen now, don't you? We're going to have the current going into that conductor. We're going to come out of that conductor, and now all of those lines of flux will combine, and now we have rotated the magnetic field 180 degrees. And that's it. Pure and simple. If you understood the bar magnet for the electromagnet in first year, the three-phase induction motor does the same thing. Hope it helps. See you tomorrow.